So now, last but not least, we're going to look at the generic reaction mechanism for nucleophilic addition. Nucleophilic addition can occur in either acidic or basic solution. So the nucleophile, the reactivity can be catalyzed by an acid, or the nucleophile can be extra basic. And we're going to start by looking at the reaction that would occur in basic conditions. And for this, we're going to use acetone as our carbonyl compound, as our example. This also works with aldehydes, though. And we're going to be we're going to do the nucleophilic attack with just a generic nucleophile that we're going to call NuC-. It's going to have, because this is basic, it's going to have a full-on negative charge on that nucleophile. So keeping in mind that the carbonyl carbon is positive, or partially positive, the nucleophile's negative charge is attracted to the carbon, and it's going to attack it. And when it does attack it, it's going to pop open the carbon-oxygen double bond. So we are going to get carbon-oxygen single bond, extra lone pair of electrons up on the oxygen, which means it's going to have a negative formal charge. And we have attacked and formed a bond from the nucleophile to the carbonyl carbon. So there we go. In this reaction, we're going to follow up with water because we have that O- that needs to be fixed. So we're just going to use something like water. It's not always going to be water, but something with a proton on it that we can use to protonate that O-. And we've made an alcohol. There's a whole bunch of different nucleophiles that we can use to do this reaction. We're going to go through all of them in this chapter, as you can imagine. We're going to look at cyanide as a nucleophile for this reaction. We're going to look at R- as a nucleophile, and that's going to come from a Grignard. We're going to look at H- as a nucleophile for this reaction, and that's going to come from one of our hydride reagents like LaH or NaBH4. And we're also going to look at a special, I'm not going to write it on here because it's just kind of weird, but we're going to look at a special reaction called the Wittig reaction that is a basic nucleophile that we can add to a carbonyl compound. So now let's look at the acidic condition reaction. The mechanism for acidic reactions is usually a little bit trickier, and this is no exception. So here is going to be our generic acidic reaction. And for this, again, we're using acetone as our carbonyl compound. And this time, because we're in acidic conditions, we're not going to be attacking with NuC-. In acidic conditions, we can't have negative formal charges. That's basic. Acidic conditions are positive formal charges. So we are going to be starting this reaction with some sort of positively charged acid, usually a catalyst. And we're going to abbreviate in this generic mechanism H-nuc. So this would be a protonated nucleophile. Like it could be H3O+, or it could be an alcohol that's been protonated like CH3OH2+, something along those lines. These reactions, I've said this 100 times, anytime you have an oxygen in the presence of an acid, the first thing that you do is protonate the oxygen. Always, no exception. So that's something that you're already used to doing. So we get this guy right here. Now what happens next in terms of drawing the mechanism really kind of depends on what book you're looking at. Sometimes we'll like go step by step here. Sometimes people will say, okay, next thing that happens is resonance. Move the electrons up to address that positive charge on the oxygen and put that positive charge down here on the carbon instead because it's better in that spot. And once we get to that place, we've got over here, we have this nucleophile that's lost its proton. It's not charged, it's not nuc-, it's just a nucleophile. And it is going to attack our carbon. And that's going to give us Same product that we got in the basic reaction. We could also, like, so drawing out this resonance structure business, a lot of times, like, nobody really wants to do that much. So another option, I'm going to write it underneath. This is sort of an abbreviated way to do it, and this is the way I like to do it because, you know, I'm lazy. Take the nucleophile and just go straight after the carbonyl carbon and open up that bond, that double bond, all in the same step. It just spares us from having to draw one more structure. Get the same product. So for this reaction, the nucleophiles that we use in this reaction, and this is referring to these nucleophiles right here, not the H-nuc stuff that we started with. The nucleophiles that we'll see for this are water, are just our typical weak nucleophiles, alcohols, amines that have at least one hydrogen on them. And that's all it is. That's all there is to that mechanism.